let's cross out, I think it says 4.5 there. Cross out 4.5, we're going to change it to 6.2, just so that you have the correct lesson number in the sequence. And we have two learning targets for today. So let's take a look at the first one. It says, given two functions, we wanted to compose new functions by inputting one function into the other. All right, so I'm going to call this here learning target number 1 was creating a composition of functions. All right, so given two functions, I am going to call them f of x and g of x, although they could have a different name. We can compose new functions by inputting the whole function into the other. So with our two functions, there's actually two ways that this can look, because we can go two directions as far as which one gets plugged into the other. And so one option is called f of g of x. And the way this one works is that we input g of x into f of x. And the way we say that, I'm just going to write out the words here, is f of g of x. So the entire function of g of x becomes the input into f of x. Now here's the other direction. We could just do it the other way. So we could do g of f of x. And for that one, we're going to input whatever little piece is on the inside. So in this case, we're going to input f of x into g of x. Just writing it out there again, g of f of x. All right, the second learning target here was to evaluate a composition of functions for given input values, meaning instead of it just being an x, like suppose we have a specific value like 3 hours, we want to know the actual profit if the input is 3. So I'm going to write here evaluating f of g of x for a constant, and I'm just going to call that constant number c. It really just means like some regular number. All right, so if it's in the order that we've listed here, so if it's f of g of x, meaning the g of x part is on the very inside, one way that we can do this is to plug c into g of x, get an answer. We're going to call that answer the output. So then we're going to plug that output into f of x. So that's exactly what we did in the activity with that table we made. So we knew a specific value, like t equals 3 hours. We took 3, we plugged it into the number of pi function, we got an answer, and then we took that answer, that output, and we plugged it into the profit function to get our final answer. All right, so that's one thing that you can do. There is one other option. So another way to do it is to actually write the composition f of g of x in terms of x, so composing the functions but keeping the variables in there, which is kind of like what we did in the activity back there in number 5. So that's where we have the composition written out, but notice how t is in that formula. So we can get it in that form, and then we could just plug our specific value in for the variable there. So I'm just going to say at the end here, just plug c into the composition. All right, so we're going to take a look at a few more problems together here. So in our check for understanding, they are giving us 2 new functions. We've got v of x is 3x squared, and we have w of x is 4x plus 1. So let's take a look here at part A. So part A is asking us to find v of w of 3. All right, and this is kind of like what we just wrote out for that second learning target. So we're wanting to evaluate a composition for a specific value. So it's telling us the value of the variable here is 3. We want to simplify this down. Our final answer is going to be just a regular number. So the first option for how to do it is to take 3 and input that into the w function. So really just finding w of 3, which is just going to be plugging in 3 in the position where we see the x on the right-hand side. So we have 4 times 3 plus 1, 12 plus 1, ends up giving us an output of 13. All right, so that's the first step of this. Then we're going to take the output of 13 and we're going to plug that into the function that was on the very outside, the v function. So that 13 is going to go into this one. So really what we're doing is we're finding v of 13. And whenever we see something like this, we want to be really careful that we're always doing our exponent part first before we multiply. So that's just order of operations. So we want to do 13 squared first to get 159. Then we'll multiply that result by 3, and we get a final answer of 507. All right, let's take a look here at part B. So we have the same order of the composition. We're still thinking about doing v of w, but instead of a specific number here, we have a variable. We want to do v of w of x. So we want to keep x in the process. We're going to have an x in the final answer. So the idea here on this one, looking at that function on the inside, this w of x, that whole function is going to get inputted into v. So we're going to take this whole function here, which is really 4x plus 1, and that's going to get inputted where the input goes in the v function. So instead of writing it as 3x squared, we're going to be inputting 4x plus 1 in the place of where the old x used to be. And because there's two pieces to the 4x plus 1, I'm going to use parentheses around it. We still have the 3 multiplied in front. We still have the squared on the outside. All right, if we wanted to simplify this down a little bit further, we could. That 4x plus 1 squared really means 4x plus 1 is being multiplied by itself. And to save a little bit of time here, I'm just going to talk aloud what we would do. For the next couple of steps is we could FOIL the two parentheses parts together, get an answer, and then distribute the 3 in. So that would just be another way that you could simplify it even further. So the other way that you could have evaluated part A would be to figure this part down here first, part B, and then you could have taken that little input of 3 and just plugged it into this answer. You're still going to get the same final result of 507. I actually think that what we did in part A is maybe a little easier. So this time when we're putting we're putting V as the input for W. So all we're going to do here is take the 3x squared, and that's going to get inputted for x over here in the W function. So instead of writing 4x plus 1, we're just putting the 3x squared in place of the x. So if you multiply